Today I'm going to start with your review for your final exam. I'd like you to take your own notes, and I'm going to try to give you some important ideas about the first part of your final exam review. So first of all, I'm going to start with Chapter 7. Chapter 7 was exponential equations and log equations. So the first thing that we did in this chapter is learn how to graph exponential growth and exponential decay equations. So what I'd like to do is remind you how to graph these and what some characteristics are. So take out your calculator. Let's graph this first. Y equals 5 to the x. If you will, make sure you hit zoom 6. That'll get your calculator back to regular. And remember, if the number in front here is bigger than 1, then we're going to have a growth. So my idea today is to go over a couple of these examples with you. Take your own notes, and then this will actually get you through the review problems in the first section. This should probably get you through questions 1 through 15 on your exam review. So we can see this kind of grows. Remember, if I go to my second table, I can get some actual points. If your points aren't in the right spot, hit second table set and say start at 1 and go up by 1. And then when you go to your graph, you'll get some exact points. So let's graph the point 0, 1, 1, 5, 5, negative 1.2. And on your exam, just like we did in class, you're going to be asked to tell the domain and the range. So remember, the domain is how far right and left you go. Range is how far up and down you go. So these go forever and ever left and forever and ever right. So we say all reals. Exponential growth mellows out at 0 and goes up for forever. So we say y is greater than 0. On the next example, notice that B is between 0 and 1. This will become a decay problem. And when we talk about a decay problem, our graph will kind of go opposite. So again, let's graph this. We have a y equals, we can put 1/2. Again, make sure that when you're using exponents, use parentheses. And when we graph it, we can see it's a decay problem. Get some points. At 0, we'll have 1. At negative 1, we'll have 2. At 1, we'll have 1/2. So our graph will kind of come down this way. Domain is how far right and left we go. Again, that's all reals. Range is how far up and down we go, which is y is still greater than 0 because it mellows out at 0, but it goes up for forever. The next idea that we did with exponential growth and decay were word problems, and our formulas for growth were A equals P times 1 plus, because we're growing R over N and raised all to the NT. The decay problems were the amount of money or interest that we have is our principal, and 1 minus R raised to the T, because this is our decay, okay, and this is our growth. So a quick review of what all these variables stand for. P is what you start with. R is your rate, but remember to put that in decimal. So if you have 7%, this would be 0.07. N is the number of times we compound. So if we compound once a year, monthly, weekly, daily would be those values. Okay, so take a minute, hit stop, pause, and make sure that you get all of these values. T is time, and that's usually in years or days. On our decay problem, again, we still have what we start with. This would be depreciation problems. So we'll have an interest rate that the particular, in some cases, the car decays or depreciates. Again, if that's a rate, if it's 12%, you'll put 0.12 in for a decimal, and T is your time. So make sure you get your formulas for decay and appreciation. The third thing that we did in this chapter were logarithms. So the first thing we did was learn how to translate logs. So we have log to the base b of y equals x. Translates to b is your base, x is your exponent, and y is what's called your argument. So it's very important. You're going to need to know how to translate your logarithms. You're going to need to know how to graph a logarithm. And the easiest way to do this, again, you can do this with your calculator. Let me show you how to show that on your calculator, and then we'll go with some more rules. So to get to the log to the base b of x on your calculator, you will hit alpha and then window. So if I hit alpha and then window, a little pop-up screen comes and you get your log to the base. So we'll hit base 6. We'll put x into the argument, and when I graph it, we might remember that logarithms and exponential are inverses, so they're going to go the opposite direction. Again, if I get some points, I should see a point 1, 0. Let's kind of come down here a little bit and see if I can see another good point. There's a point 6, 1. And look at your graph to see how it mellows off. Again, you'll be asked to tell the domain and range. So the domain is how far right and left this graph goes. It doesn't go forever and ever left. It only goes to 0. So x will be greater than 0. And the range is how far up and down this curve goes. And this time, that will be all reals. We also did some solving of logs in this section. And again, the key that you're going to want to remember is this rule. If I give you a log equation, you'll be asked to put it in exponential. So again, 5 is your base. This thing on the other side is the exponent. And what does that equal? That equals the argument. You'll also be given a exponential equation and asked to put it in log. So if it's exponential, we'll put log. B is your base. This 36 is what the argument is, and the exponent goes on the other side of the equal sign. So you'll be asked to solve some logs. Some easy ones will just be log the base 5 of 26. How do we solve that? Again, just use your calculator. Remember to hit alpha, window, and just plug in. Okay, so if I hit alpha window on my calculator, I'll get the log option. And log the base 5 of 26 means what? 5 raised to the 2.02. This means 5 raised to the 2.02 equals 26. And that should make some sense to you because we know 5 squared is equal to 25. If I ask you with a variable in here and solve for x, you're going to have to know how to translate. And again, b is your base, so 3 is the base. The thing on the other side of the exponent is the exponent. Once we get that translated, now I can solve for x. And we'll just think of it as an algebraic equation. When you're asked to solve for log equations, and we have logs on both sides, just do a quick check. If the logs are the same, which the log, remember the base is 10 if it's not there, they're the same. So if they're the same, all you have to do is set the insides equal to each other. So in other words, I would set 2x plus 5 equal to 7x minus 12, and then just solve for x. So again, hit pause if you need to set this up. If I'd subtract off 2x and add 12, I'll get 17 equals 5x. Solve for x, I get x equals 17/5. Second example of this, check to see if the logs are the same. Remember when we see ln, that really means log the base e. If they're the same, they are same on both sides, then all we have to do is set the 4x plus 3 equal to 5x minus 7. Solve for x. We get 10 equals x, and that's it. So looking through your notes for Chapter 7, just a quick recap. You'll need to know how to graph a growth, a decay. You'll need to know both of your formulas and how to use them. It's important that you know how to change a logarithm to an exponent. You'll need to graph a log, and then you'll have to solve using your calculator. So again, make sure that you know how to punch your calculator out and then translate so you can solve some logarithms. Okay. These notes should be able to get you through the final exam review 1 through 15. Actually, in the exam review, 16 through problems up to 30 are your Chapter 8, which we just got done doing, but I'll have a little video on that for your review as well.